Okay, today we're going to be looking at solubility. Now, that word might be one you are familiar with, or it might be one you've never heard before. So, we're going to start out here with some vocabulary. Starting with, what is solubility? Solubility is the ability to dissolve. So, anytime we have a substance dissolving in another substance, we're talking about it having some sort of solubility. Okay, something that is insoluble means it will not dissolve. And something that is soluble means it will dissolve. Now, substances can be soluble or insoluble in different materials. So some substances will dissolve in water, but they won't dissolve in oil. So solubility is really dependent on many factors. Couple more vocabulary terms here. The solute is the thing that is dissolving. Most often this is the thing that is in smaller amounts, and a solute can be a solid, liquid, or a gas. So we can talk about a solid dissolving, we can talk about a liquid dissolving, we can talk about a gas dissolving. The solvent then is the thing that is doing the dissolving. Most often this is the thing in a larger amounts, and most of the time we're talking about aqueous solutions, so materials that are dissolved in water, where our solvent is the water. And again, we can talk about solids, liquids, or gases being our solute in our solvent. So some examples, if we make a saltwater solution, that would be a solute dissolved in water, so an aqueous solution. We can have some food coloring, right? Food coloring is typically a liquid. We can dissolve that in water, and that would be a liquid solvent, a liquid solute in our water solvent. We can talk about gases dissolving. So if you have one of those soda stream machines, I know I have one at home, to make like bubbled water. You put water in the bottle, you hook it up to the machine, and you push the button, and it forces gas into the water, and it dissolves that gas in the water to make it bubbly. So if you think about soda or any sort of thing that is carbonated, that is simply a gas dissolved in a liquid. Okay. We do have more vocabulary. There's lots of vocabulary here in this unit. When we're talking about a saturated solution, that's a solution which can hold no more solute. So under the certain conditions set forth, that solution has as much solute as it possibly can hold. An unsaturated solution would be just what we think. It's a solution that can hold more solute. So it is not quite to that point of saturation yet. A supersaturated solution is a solution which holds more than the maximum amount of solute. Okay, now you're like, what the heck? I thought a saturated solution can't hold any more solute. How do we get to a supersaturated solution? So we have some factors that affect that level of saturation. Which means we can kind of play with that level of saturation and make solutions which are supersaturated. Some factors that affect solubility. Pressure. When we increase pressure, more solute can be dissolved. So if we think about that gas dissolving in a liquid, pop cans are held under pressure. And when we release that pressure, the gas comes out. And if we leave a pop can open for a long period of time, it's going to go flat, right? You're going to drink it and there's going to be no more carbonation in it. That's because all of the gas that was dissolved in there has now escaped because the pressure went down. So if we increase the pressure of something, we can usually make more solute dissolve. The molecular size, small molecules dissolve faster or easier. Now this doesn't mean that like we're looking at molecular mass. It actually means like the actual physical size of a particle. So if you think about like salt, when we have a really big chunk of salt and we just stick it in a cup of water, it's not going to dissolve, right? It's going to take a long time because the water can only touch the surface of it, and there's a lot of salt that water isn't touching. But if we have little teeny tiny grains of salt or even a powder, it's going to dissolve way faster than that big chunk, okay? Agitation, so that's stirring or shaking or anything like that. And this moving the particles allows more to dissolve. kind of like what I just said in molecular size, where the solvent is touching the solute. When we shake something up, we're moving all those particles around and we're making them bump into each other more, which increases our ability to dissolve. Temperature. Now, this is the one we're really going to focus on here in the next few minutes of this video. As temperature increases, more solute will dissolve. So think of this like you're making tea, okay? Now, we can drink tea cold, we can drink tea hot, we can drink at room temperature. But if you're going to add sugar to tea, you need to add it when it's hot. Otherwise, that sugar is not going to dissolve well. You've probably experienced this, or you can try it out at your house. If you add sugar to cold water or cold iced tea, it's not going to dissolve super well. But if you add it to hot iced tea, it dissolves, or hot iced tea, hot tea, it dissolves, really well, okay? And that is because of the temperature. Now, if we think way back to the start of the year, we looked at temperature and how that changes our particles. When temperature increases, the particles are moving faster, okay? And like I just said with agitation and molecular size, when those particles bump into each other, that's what causes the dissolving. So if the particles are moving faster just because they have a higher temperature, they're going to allow more things to dissolve, okay? So this leads us into solubility curves. And now solubility curves show us the amount of solute that is able to dissolve in a certain amount of solvent, okay? And it compares that amount to temperature. These can be used to determine the temperature needed to dissolve a certain amount of solute. If we look above the line, we have a supersaturated solution, or the solution would not be able to occur. If we are on the line, we have a saturated solution, and if we are below the line, we are unsaturated. Now, this is going to make sense when we look a little bit more closely at this picture. So on this picture, you can see that we have temperature down here on the bottom of our graph on the x-axis, and the solubility on the y-axis. Now, solubility says it's the grams of the salt, so this is any salt, not like table salt, in 100 grams of H2O, okay? So at 0 degrees, you can see all of these different amounts of salt that can dissolve at 0 degrees. When we go up, we have a different amount as we go up in temperature. Now, notice there's only one of these that actually decreases in the amount of stuff that'll dissolve as we increase in temperature, and that's why we said generally we get more. But if I, say, had a 50-degree Celsius solution, and I wanted to dissolve as much KCl as I could dissolve about 42 grams. See, I have this KCl line, and I'd go over to 50, up to the line. Okay, now that would be a saturated solution. If I wanted to make a supersaturated solution, what I would do is I would increase my temperature, dissolve my substance, and then I would slowly cool it down. And that slow cooling process keeps the material dissolved, but it lowers the temperature, so then the solubility goes down, right? Because if I took and I dissolved that 42 grams of KCl in my 50-degree water, and then I lowered it down to 30 degrees, I would have a supersaturated solution because I would have 42 grams dissolved in something that really should only have 35 grams dissolved in it. Okay, you will get some practice at reading these solubility curves and determining if things are saturated, supersaturated, or unsaturated in some of your practice activities. As always, if you have any questions, make sure to reach out to your teacher.